Hello and welcome everyone. So today we'll be constructing a circuit, LED circuit, basic one. Not really, LED circuits can vary. So basically we're gonna be constructing a very basic one, which is whenever the button is on, so the LED will work. Whenever it's off, the LED is off. So we will first construct our circuit by using the software, which is Proteus ISIS, sorry. So let's go and find the software. Yes, this is our software. We're gonna build our circuits. Very basic LED circuit. Yes, okay, and let's cancel this. All right, so let's start with constructing our circuits with the basic objectives. Here we can pick from our library. This is how we choose our components. First, let's start with the for this circuit we'll be choosing the PIC 18F4550. So we'll be using this microcontroller for our circuit and press OK. So we are having it over here. This is our microcontroller. This is what we're gonna use for our circuit, for our LED circuit today. All right. So this is our microcontroller. Let's start constructing our circuit. We need our LED, of course, from library. This LED, and we have a lot of types of LED. Our preparation goes to LED BIBY. It has colors. All these are colors from blue, yellow, green, amber, red, green, whatever. So you can pick up your, it depends to your preference. We'll go with blue and yellow. Okay, so this is our LED over here. You can also rotate that left or right by pressing the plus or the minus button in your numlock. So this is our LED over here, and we needed just a very small resistance. Okay, so resistor. So resistor just connected here in series with our LED, just a very small one. The value is already set to 10K. You can just double click it and change the value with just a very small value. Let's say 300 ohms. That's a random value. You can vary that value as well. Secondly, we go to the switch, to the button. So go pick from library, button, and yep, that's our button. Replace our button over here. So to rotate this. This is our button over here. Alright. Okay, let's put after our button, let's get into another resistor, and I'll be explaining why we are putting this resistor over here. While we are constructing the circuit, while we are connecting and wiring everything, I'll be explaining why am I putting this resistor over here. Alright, so let's start by connecting this over here. This is our switch button, so it's connected to RP0, pin number 0. We'll be connecting this to our pin 0 here as well. It's okay, you can just edit that. And of course, it's connected to our LED. We need our ground terminals for sure. Here will be our ground terminal, so you just choose place, terminal, then ground. Sorry, place, terminal, and then ground. So we place our ground over here. So ground for our LED, another ground that we need for our switch. So you just same steps, place, terminals, and then ground over here, and Okay, you're done with this. So also we need our, okay, let's connect this first. That's why this is connected over here. This is connected over here. And then we need also our power supply. So it's the same steps: place, terminal, and then power. So we need a power supply over here. We need another power supply over here, which is gonna power up our controller, microcontroller. Connect it over here. This is our power supply over here. Now I'll be connecting this here. Why we are adding this resistance? Okay, this resistor is basically we can connect this directly theoretically, but practically it's impossible because it's gonna be short circuit. So this is not what we are looking for. We'll be changing the value from 10K to, let's say, just 1K. Right. So yes, this is our circuit. It's constructed. The button is here, switch on and off. So let's go to the coding. For the coding, we'll be dealing with MPLAB. Alright, loading. So start with a new. This is our file. We go to the save as. We choose this as, of course, I've chosen the file from desktop. So as you can see, choosing the file from desktop, LED project, it's already there. This is our file, and name in our file is going to be, let's say, led.asm. Save, and then let's start our project. Next, make sure that the device that we're dealing with is the same device that we have chosen already, which is PIC18F4550. Next, let's browse and then rename it LED. Okay, it's just in the same file. Done. Next, so LEDSM. Next, finish. So we got our, here we're gonna start doing our coding. So the purpose of the coding over here is to check the status of the switch, of the button, whether it's 0, which is low, that means the LED is gonna work, or either it's high, which is 1, and that LED is not gonna work. So how we gonna do this? First of all, we start with some basic. Include P18 F44 F0 stop. Ink goes up. So here we'll start with some basic that we have already supposed to be already memorizing this. Or 0 0 0 got 2 start. We have for org 0.8. All this we have already memorized. I mean, it's a basic start. Say this is how we basically start with the code. We have our org 0x18, and we got our, okay. So now let's start with the coding. That's already started with the coding, but I mean our main purpose of being here, which is starting with the coding for the LED switching off and on. So let's start with some configurations. Configurations comes first, of course. So we'll be starting with start clear F. So what is the purpose of this? There's D A. Okay, what we are doing over here, we are setting our output to be the D over here. As you can see, D over here is our output, is connected to the LED. So now we are setting by using this instruction, we are setting the output to be the pin D, and of course we need to set our input, set F, our input to B. Alright, as you can see from our circuit over here, our input is B, so we are setting that in the code that our input is B, as it is connected to the switch. This is what I'm gonna do now. It's an additional step, which is making sure that both port D and port B has no values. I'm trying to make sure that there are no values at all, to do not, for any errors happen later on. It's just an additional step. Okay, we are done with this. Let's go to our next. We'll be having, yeah, so basically that's the beginning of our code. Now we'll be checking the condition of the switch button. What I mean by that is we'll be checking whether it is, as I said previously, it's on where the LED is, where the set is 0, or off, this active, or 1. So let's start with, okay, let's call this our check, and for clarification, to make sure that everything over there is correct, let's build our program over here. Salute. Okay, success. What I have done just now is just to make sure that what I have written above is correct. So let's end this and continue our work. So as I said, now we will be checking the status of the button of the switch, or the switch. So how do we do that? We will start by using the instruction BTFSS. And what do I mean by that is bit test file skip set. And that means whenever the input is set, it's gonna skip the next instruction and go directly to the one after it. So we'll be building first. What we are building first is when is the LED is off. The LED is off. That's what we are gonna work on. So let's start with this first statement or first situation where the LED is off. So basically, we are dealing with port B right now, which is the input 0, 8. So whenever it's set, it's gonna skip the next instruction. So let's skip the next instruction and go directly to, as I said, now we are dealing when the LED is off. So let's continue as it is. So after that, we'll be going to bit clear file. What we are clearing over here is bit clear file port D0A. So basically we are clearing port D, which is our output. Let's move on to the next, where we have branch. We wanted to branch again to the checking statement, because basically what we are doing right now is just checking whether it's whatever is set, then it's gonna jump the next instruction and directly jump up to, going to port, giving the low output, which means that the LED is off, and then it will go directly to check again. So that's what it's doing, what is happening right now. So let's say, what if the input wasn't the set, which is 1? Then we will go with we want to branch over here to, let's say, on LED. So we haven't defined on LED yet, so let's go and define that on LED. So what we are looking here is the situation where the LED is on. So basically we are bit SF, which is the bit clear file, port D, yes, we are dealing with the port D, yes, we are dealing with the output right now, 0 A. Okay, now after that we'll be branching again to the statement check. So if the input was low, which is 0, then it will branch to on LED, and then for D the output will be 0, the output will be 1, the output will be 1, which means the LED is on. Then after that it go and check again for the condition. So this is an endless loop. This is an endless loop where it will be checking all over again and again and again and again for whether it's 0 or 1, and to give you a specific output. So after this we will have our end over here. Then yeah, that's it. Let's try and build our code over here. Succeed. That's good. So that means everything is correct. So we have our code over here. Let's go now and start with export. Okay, we want to export this. Yes, just overwrite whatever you have over here. Just overwrite it, and yes, you are done with it. Okay, let's go now, and yeah, after we have done with our export, let's go to Proteus again, to our software, to our circuit. We are here. Alright, let's go to, okay, so let's right click on our microcontroller, edit properties. But yeah, just there is one step that I have forgotten just now. Just go to the configuration over here, get back to the configuration. There are a few configurations that I need to reset again. So we'll press on our first of all, you uncheck this. Okay, press on our FOSC and choose HS. Alright, and after that we'll be moving to watchdog timer and make sure it's disabled, and then to port 80, let's make sure it's second one, and then lastly we'll go to the LVP and make sure it is disabled as well. So right now everything is done, so let's just minimize this, and for confirmation purposes let's just build our code again and make sure it is succeed. Pause this, and yeah, let's do our export again. Okay, and just overwrite whatever you have over here, just overwrite it, that's okay. Let's go now to our circuit, and I'll be doing this again. Right click, edit properties, and go to program file, choose our hex over here, open. Okay, it's over here. Set this to 20 megahertz. Okay, so I think we're ready now to start playing our circuit over here. So let's try this. Yes, and it's on. So basically now the blue dots is indicating whether it's an active 0. I mean the blue and red dots indicating whether it's 0 or 1. So we know that for our LED over here needs the value of 1 to work, and for our switch over here need the value of 0 to work. So as you can see, it's working. So we just switch on and off, this is what we were talking about on the LED at the beginning, just yellow, the colors blue. So yes, this is how we construct our LED circuit. Thank you very much for watching. I hope that that was beneficial and informative. Thank you so much.